Ever take one of those online personality quizzes?
Mhm.
You know, the ones that tell you, like, what kind of cheese you are or what your Hogwarts house would be?
I have to admit, I've clicked through a few of those myself. It's fun to, see what they come up with. But
Right. But, like, how much can we really trust those results? Like, are they actually consistent?
that's a great question. And it gets to the heart of what we're diving into today: reliability.
Ah, yes. Reliability. We're going deep on that today. We've got some notes from the awesome Professor Bubblegum and some insights from Bruce Frey, who literally wrote the book on this stuff.
Sounds like a solid lineup.
So by the end of this deep dive, you'll understand the key ways we measure reliability. And maybe, just maybe, you'll be a little more skeptical next time you see a result that claims to be guaranteed accurate. No promises, though.
A healthy dose of skepticism is always a good thing, I'd say.
So let's just jump right in,
Yep.
okay? What exactly is reliability, like in plain English?
Well, at its core, reliability is about consistency. Can we depend on something to give us the same or very similar results over time?
Okay, so like if I step on a bathroom scale.
Exactly. A reliable scale will show you roughly the same weight each time, assuming, you haven't suddenly gained or lost a bunch.
Uh-huh, right. Unless I've had a really good or really bad day.
But think about it. We rely on consistent measurements all the time, right? Product reviews, medical diagnoses, even just deciding what to eat based on an online recipe.
I see what you mean. So how do we actually measure this consistency? Because, like, we can't just, like, hope things are reliable.
You got it. And that's where these different types of reliability come in. Professor Bubblegum mentioned retest reliability. Any thoughts on that one?
Well, it sounds like it has something to do with taking a test more than once.
You nailed it. The idea is if a test is measuring something real and consistent about you, your score shouldn't change wildly each time you take it, right?
So if I took that, what kind of cheese am I quiz today and again tomorrow?
And assuming you haven't, undergone a major cheese transformation overnight.
Uh-huh, exactly. My results should be pretty close, right?
In theory, yeah. Of course, in the real world, there's always some variation. But the closer the scores, the higher the test-retest reliability. And to measure that closeness, we use something called a correlation coefficient.
Correlation coefficient. Ooh, that sounds fancy.
It's actually pretty simple. It's basically a number that tells us how strongly two sets of scores are related. A high correlation, say like zero point 0.8 or zero point 0.9, means the scores are very similar, so the test is considered pretty reliable over time.
Gotcha. So we're looking for that high correlation to be confident in the results. But wait, we can't give someone the same test like a million times, right? That wouldn't be very practical.
True, and that's why we usually estimate test-retest reliability with just 2 administrations of the test. But it's a good starting point.
Makes sense. Now, what about when we have like a test with a bunch of different questions that are all supposed to be measuring the same thing? Like I'm picturing like a super long personality quiz with tons of questions about introversion, for example.
That's a perfect example of where internal consistency comes in. This type of reliability looks at how well all the questions or items on a test hang together. If all the introversion questions are actually measuring introversion, then your answers to those questions should be consistent, right?
Yeah, it wouldn't make sense if I answered strongly agree to one introversion question, but then strongly disagree to another one, unless I just wasn't paying attention.
Exactly. And a cool thing about internal consistency is that we only need data from one test administration to calculate it. It's like a shortcut to get a sense of reliability.
That's super helpful. But Professor Bubblegum also mentioned some potential problems with internal consistency. What were those again?
Right. The big thing to remember is that a test can be internally consistent, meaning all the parts fit together neatly, but it still might not be measuring what it's supposed to measure. It's like a puzzle where all the pieces fit, but they make the wrong picture. You know what I mean?
Okay, that makes sense.
Yeah.
Like imagine a test that claims to measure intelligence, but all the questions are actually about like pop culture trivia.
Precisely. You could get a really high score, meaning the test has great internal consistency, but does that really mean you're super intelligent? Not necessarily.
So internal consistency is a good clue, but it's not the whole story. We still have to be critical about what the test is actually trying to measure.
100%.
Now, what about situations where we have like multiple people judging something like, think about Olympic diving, right? Or even like grading essays.
That's where inter-rate reliability enters the picture. It's all about how much agreement there is between different judges or raters. We want to be sure those judges are scoring consistently based on, the actual performance or quality of the work.
So it's not just about like everyone giving the same score.
It's more about consistency in their judgments. Like, if one judge consistently gives higher scores than another, that might signal a problem.
Yeah, we want to minimize those individual biases as much as possible.
Totally. And there are different ways to measure inter-rater reliability. Sometimes it's simple, like calculating the percentage of times the judges agree. Other times we use fancier stats like correlation.
Makes sense. Now, last but not least, we have this thing called parallel forms reliability. What's that all about?
This one's especially relevant to like big standardized tests. Think SATs, ACTs, those sorts of things.
Ah, okay, those high-stakes tests that make students super stressed out.
Exactly. And with those tests, it's really important that all the different versions of the test are equally difficult.
Yeah, because it wouldn't be fair if I got an easier version than my friend and then our scores were compared.
Right. So test makers try to create parallel forms of the test, basically different versions that cover the same material but with different questions, and make sure they're all equally challenging.
So parallel forms reliability helps ensure a level playing field, and it also makes it harder to cheat, right? Because you're not going to see the same questions if you retake the test.
Precisely.
Wow, we just covered a lot. We talked about test-retest reliability, internal consistency, inter-rater reliability, and now parallel forms reliability. It's amazing how much goes into making sure the measurements we use are actually reliable.
And it's something we should all be thinking about more in our everyday lives, because reliability isn't just for scientists and researchers, it's for all of us.
Absolutely. So next time you're reading a news article or a product review or even taking a fun online quiz, think about the reliability of the information you're getting. Like ask yourself, how consistent are these results?
Or who are the sources of this information? Are they likely to be biased in any way?
Great questions. By thinking critically about these things, we can make better decisions and be more informed consumers of, well, pretty much everything. It's about not just blindly accepting what we see and hear.
And on that note, I'd challenge you to think about this. How do you think the rise of social media and the constant flow of information, some of it true, some of it not, has impacted our ability to judge the reliability of what we encounter online?
That's a great question to ponder. We'll have to save that for another deep dive. Until next time, stay curious, stay skeptical, and keep questioning the world around you.
See ya.